Hello, everyone. My name is Derek Pizarro. I'm a senior geologist with AST Environmental, and thank you for joining me today. The title of this presentation, High Energy Injection of Permeable Reactive Transects for Treatment of Hexavalent Chromium in Varied Geology. I will present this today as a case study, also drilling down into some of the technologies and techniques we deployed at this site. But the idea here is that this is a case study flow presentation for you. So it should go start to finish as kind of a whole concept, right? Installing product in a challenging geology. I put this slide up just to give you a quick overview of who AST is, but also to show a couple concepts that we're going to talk about today. Focusing on overburn injection, we're going to do a modified version of that coupled up with GeoTAP to install what is a modification to a contemporary PRB at this site we're using as a case study. Just as a quick note, AST does deploy offices across most of the US. I'm based outside of Philadelphia in our Pennsylvania office. We're headquartered in Midway, Kentucky, which is just outside of Lexington. But we also have offices in Colorado, Kansas, Ohio, and Virginia as well. So let's talk about this site. Again, every site is unique. So we're going to take approaches that we've used at other sites and modify and adapt them to fit the uniqueness of each site. This one is no different. So this site is in the Northeast US. It's a former industrial manufacturing facility that has been torn down. There's a large hexavalent chromium plume and a specific groundwater unit at the site that typically ranges in depth from 45 to 90 feet below ground surface. We'll talk about how we target that coming up in a few slides. There have been some earlier remediation efforts at the site. There are some other sections and areas that did require treatment prior to now. Those were addressed with disposal, treatment and disposal. There's some pump and treat, some other systems and techniques being deployed out there too. What's unique about this site is it is in a zone of a tight silty sand and gravel. It's also underlain by a glacial till. The zone we're targeting does tag into that glacial till in some areas, so we're including both in this as a challenge, which it certainly is. And because of those zones, consistent access is difficult. And it gets even more challenging as we go down towards the lower depth of some of these transects, again, tagging as far down as 90 feet below ground surface. So what are our options for installation? We're going to be showing you the GeoTAP technique here today and also using injection of Ferro Black reactant to treat the hexavalent chromium. But also at the outset, other installation methods were considered. Yellow iron, not really a good option because of its depth. Fracturing was considered, but again, fracturing is a different means and method than high energy radial mixing that we're dealing with here today. So that wasn't going to affect the distribution that was needed here to treat this, to treat these transects of, or excuse me, to install these transects for treatment of hexavalent chromium in groundwater. So some of you on this webinar may be familiar with GeoTAP. GeoTAP stands for Geological Targeted Access Point. Those of you that are not, the three things important or imperative to any injectate installation in situ is longevity, dosing, contact is the biggest one, right? So this GeoTAP, again, is access to the geology that you're dealing with to allow those things to occur. And again, we choose GeoTAP when we can't direct push, right? Direct push is a great technology, but when we get refusal with 7822, when we get refusal with even a larger rig like a 3230, we have to switch to GeoTAP. We also consider GeoTAP when we're getting into weathered bedrock, saprolite, glacial till, anything that we would need more conventional bedrock drilling techniques to be utilized, but that borehole, once installed, will not stay open, right? We need to find a way to keep that borehole open. We've been asked in the past, is this a replacement for injection wells? Well, that's not a yes or no question per se, but we find that in these geologies, injection wells don't typically work very well. Even with a aqueous, liquid, or colloidal injectate, even if we'll go through the well screen, But here specifically, because we are dealing with true slurries, it absolutely will not go through the well screen. So injection wells are not an option to install this injectate. The best way to think about GeoTAP, and we'll go through the sequential process here on the next slide, but the best way to think about it is you're going to drill the formation like it's bedrock, but then inject it like it's overburden. And we do see, again, because this does typically get deployed in weathered or saprolite zones headed towards bedrock, consolidated material, it is combined with bedrock remediation. Here, though, it is not. It's strictly an access, a means of accessing the depths in this geology. So this is just a nice way to look at how we build a GeoTAP column. And the first thing we do is we pre-drill each location to the targeted depth. You can use augers, but I typically use sonic. Again, sonic is expeditious, it's efficient, and the best part is we can log the lithology sequentially as we go. And that's really important here at a site like the one we're dealing with today, because we need to identify the top and bottom of this transect. The hexavalent chromium in groundwater is moving in a very specific geologic unit. It's readily identifiable at the top and bottom. So this logging of soils allows us to very succinctly target that zone. But we have to know where it is, because this zone does thin and thicken as you move across each transect. And each transect is different from the one adjacent to it as well. So this allows us to very accurately target the zones we're in and determine how many injection intervals we need within that zone, within that point. Some points may have more injection intervals than others within the same transect even. So after we pre-drill this hole with sonic, we then install an engineered bentonite backfill. We build it in lifts with sequential hydration. And this builds a nice bentonite column that we can probe right back through with, in this case, a 7822 rig. And then we just treat it like an overburden injection, right? The high energy of injection goes through a tip that is selected for the geology. It's not a tip that's selected to cut through the bentonite. All of our tips will cut through the bentonite, but the tip has to be specific for the geology to get the distribution that you're looking for. And we always say distribution, not radius of influence at AST, because radius of influence can be misleading. So we always talk about distribution. Once that injectate cuts through the bentonite and propagates into the formation, in the lithology we're dealing with here, we're talking about radial co-mixing. We're not talking about fracture in this instance, but that is something you could do as well. In terms of deployment, this has been used at several, actually many sites across the US and internationally as well by AST and some of our affiliates. So what does distribution look like in the subsurface? Now at this site for this case study, we did not take confirmatory soil borings. So these are examples from other sites where we did do that. As an example on the bottom left with the tape measure there, that's an example of installation in a very coarse, medium coarse sand at a site. You can see the swath we've installed there. Again, offsetting injection points do need to be offset by about a foot to get this interlocking and interleaving of the total injection system. So you build a contiguous, in this case, transect or PRB, or if you're trying to completely interlock a source zone area. When we inject into finer grain materials, as exampled in the other pictures there, we do get distribution within the dendritic patterns of microfractures, features within silts and clays that are very fine. And what we've zoomed in on these pictures is, in the middle picture there, you can get a modeling effect in some clays. In other silty clays or clays you can see on the extreme left or right of this slide, you can see how we fill in those dendritic patterns of the clay or the silt that we're working with. So again, this is a very, very succinct dive on what the injection pattern at a very small scale looks like. Again, on a larger scale, it's obviously mixing into a greater swath. But we find that a lot of times, even taking confirmatory borings, it can be in some cases, unless you have a nice dark injectate like these here, and like Ferro Black that we're dealing with today, to quote, find the injectate by soil borings. Usually it's more readily done with geochemical evaluation. So we get asked a lot, is this fledgling? Is this new? Where have you deployed it? Well, here's a nice map here as an example of some places. Naturally, I mentioned glacial till at the outset. Naturally, we see this a lot in the Northeast. We've also done some sites in Washington State, very similar settings, but also as you move further into the Southeast, Obviously, saprolite comes into play as you get to the Midwest, as I mentioned, hard pan, and some other issues. So this becomes a very viable access option for you if it makes sense, depending on your geology and your delivery of slurry. So let's talk about the slurry specifically, especially the one we're dealing with here today. If you haven't injected slurries before, these are true slurries. They are suspended with energy. We don't use any additional suspension agents. We're not, using guar or anything like that. We're not using food grade or organic agents to keep these particles suspended. We're using energy. So we truly get, once the energy of injection is turned off, we truly get that immediate settling into the formation, and we allow the reaction to start immediately. We're not waiting for breakdown of a suspension agent. Ed mentioned a couple of these products here. We're going to focus primarily today. I should probably turn my pointer on here. We're going to focus primarily today on this Ferro Black. But I bring this slide up because we get asked a lot, what's the difference, right? Like on the left is a true slurry. And we're talking about injectates that are, pollen to sand size typically. But there are other ones over, like say aqueous or colloidal, that are very common in this industry. They're much smaller if they're suspended, right? Where there's even aqueous-based reagents. We tend to, at AST, use more slurries, and that's because we're typically asked to do source zone treatment or PRBs or injecting in bedrock, where we don't want these particles to move after they're installed in the subsurface, right? Especially in bedrock, those drawbacks there on the lower right hand of this slide start to come into play. Washout's a big one. And people think that washout, especially in bedrock, occurs at very high groundwater flow velocities, and that's not always the case. It can occur at even lower velocities. So again, we like the slurries because once we install it, it stays where you put it. Speaking of Ferro Black, this unique reactant was selected by the client in concert with Redox Solutions, which manufactures Ferro Black in Indiana. Ferro Black is a mackinawite-structured ferrous iron sulfide. There's mixed valencies. The ratio can be adjusted between iron and sulfur. There's multiple treatment mechanisms. So this is applicable if you have mixed metal sites, if you have commingled plumes, say you have some CVOCs in the mix as well. We did not at this site, but that would be applicable. Ferro Black starts reaction immediately, which is another benefit. Again, not using suspension agents to put this into the subsurface only helps with that. Instance once it's installed. It is a viscous slurry. It's about 12.1, 12.2 pounds per gallon when it arrives at our site. It was delivered in totes. And it's easy to realize if you've intersected or distributed the material on the subsurface, because pH does increase and ORP does decrease very rapidly. And so there's been talk in our industry about using this, what we'll call a manufactured mackinawite-structured iron sulfide versus something that's created or precipitated in situ or aggregated in situ through sulfate reducing microorganisms. Again, we chose synthesized here, and we typically deploy for a lot of the sites that AST installs this on the Ferro Black, because we're not waiting for biological processes to take effect to start treatment. Treatment begins immediately. There was a remedial design characterization conducted at this site. Most of it did focus on providing samples of groundwater and soil to the Redox Solutions team in Indiana that allowed them to evaluate both groundwater and soil mass. They derived the loadings for the client. The client passed those on to us. And then at AST, myself and a few of my fellow geologists and engineers, we went through the calculations of installation. What's practical? Is there a dilution factor? There was in some transects, right? And how do we go about installing it in the subsurface? And in the end, looking at loading rates, knowing that these are transects, multiple transects treating groundwater flow sequentially between each transect, we ended up looking at spacing typically between 15 or 30 feet at the site. Again, depths ranging anywhere from about 45 to 90 feet. So let's look at that installation. Again, the first part of this slide, the top side, that's GeoTAP process, right? We selected sonic so we could log the soils. We could identify our span in the subsurface. We took photographs. Photographs are always a great way to log, not just for a record, but also teaching, and also to be able to show the client, the consultant, what we're looking at and that we're targeting that interval, right? Identifying that succinct top and bottom interval is so critical because you don't want to waste inject it, right? If you know where you're putting it and you know the loadings you have to achieve, you're going to have success. We also installed piezometers in each transect, and this was solely to monitor distribution post-injection. When the Ferro Black was installed in the subsurface, as you saw in a previous slide, again, we can immediately check for changes in pH, ORP. We can use colorimetric evaluation. The Ferro Black, again, Ferro Black, it is a very dark, it's black to dark gray. Even once it's installed in the subsurface, it will affect the colorimetry of the water. So that was easy to do with either groundwater monitoring or pulling a bailer to check color. Schedule-wise, the sonic drilling is expeditious, but the injection goes a lot quicker. So we started sonic drilling and GeoTAP activities in advance of the drilling, about 4 weeks in advance of the actual injections. And that sonic drilling, that GeoTAP, took about 5 weeks to complete. We did overlap by a week with one area. So here's an example of our setup here. We are using a sonic rig to advance this. We're also pulling cores. Here's one of those cores on the table here that we're looking at. We're trying to find, again, that succinct top and bottom of the zone. The zone did thicken and thin depending on the transect and where we were on the site. And again, if you haven't worked with Ferro Black before, it's received in these totes back here. That's how we did it at this site. At least you can also receive it tankers. Totes are really easy to work with. So how did injections progress? Well, this is where it flips to more of a traditional high energy installation. If you've worked with AST before, again, we used a DPT rig, a GeoProbe 7822. We're using our standard injection rods for a silty sand type geology. We manufacture those tips in-house. We buy them from GeoProbe, and then we alter them to our specifications in our shop. We chose for this installation the triplex injection system. Some of you may know this kind of proverbially as the bedrock injection system. I'll show you a picture here in a second. The reason we did that is because of the injection borehole spacing, the GeoTAP spacing that we deployed at this site. Because we were on centers greater than 12 feet, we elected to use the triplex. The triplex does have significantly higher flow rates. It does have significantly higher sustained system pressures. Again, PSIG, that's system pressure, that's not subsurface. But because this system does run off the PTO drive of a Kenworth T800, we can literally just shift gears. And by changing the gear ratio, change the pump speed and flow, and we can adjust those rates to meet our needs. And so once we do that, the injectate leaves the batch system here on the back of the truck. Again, this is parked for transport. This isn't deployed at the site. But then it can flow over to a more standardized 7822 rig with a traditional DPT injection setup. If you're trying to wrap your head around what these injection flow rates look like, again, moving left to right, top, bottom, 20, 60, 120, 250 GPM. This is hooked up to a injection head that we use in medium to coarse materials just for effect. We would use something a bit different in this formation. So let's talk about lessons learned at this site, right? We started this design based upon experience, but again, it was like any site, you have to adjust real time, or some people say on the fly, but I think on the fly means you're trying to scramble. Really, a lot of the optimization we do on site at AST is rooted in past experiences and knowledge of both the system engineering and also the injectate and the geology that we're dealing with. So again, that type of experience is crucial when you're trying something that is a little bit different than what you normally do. Here's a picture of that triplex pump we were just talking about. Again, chose it because of the injection centers, chose it for propagating significant distribution to the subsurface. This pump is also applicable for bedrock installations. And a little note there, if you are doing bedrock remediation and you saw some of the flow rates and pressures on that previous slide, know that we are not using those pressures to crack rock, right? Those are just system pressures to allow us propagation. Once we get formational breakdown from the fracture, we're not trying to crack rock in those installations. And it's a similar application here. We're not trying to significantly, energize the subsurface of the site. We want a nice, concise radial co-mixing moving away from that injection tip. So here's a summary of our installation. We did this in 5 transects. Again, the design here, between each transect, we are looking at 30 years of groundwater flow. So it's a very low, very low flow zones in between each transect. But the idea is after 30 years, the groundwater that started just on the other side of one transect has now reached the subsequent down gradient transect. So this is a longer term management of hexavalent chromium and groundwater. We installed almost 35 gallons of Ferro Black. Injection took 4 weeks. Again, we drilled the GeoTAP installations for 5 weeks, injected for 4 weeks. So this whole process with a little bit of overlap took roughly 2 months to complete. In terms of assessing the installation, I did mention using the piezometers in some existing wells for the colorimetric evaluation, changes in geochemistry. It's very easy to monitor. We talked about optimization. No project really ever could you say, did you not have something you had to change in the field to affect the distribution you're looking for? You know, you can't, it's hard to say you have, you know, maybe you get a project where you don't ever daylight or short circuit, but that's, you know, that's rare. That's very, very rare. We did have a little bit of that there. We had to make some adjustments with flow rates, and that's where we took the opportunity on one transect where we were having some issues due to some former installations in the 20 to 25 foot towards ground surface depth, some former wells that were removed, some sheet piling that was removed. This allowed us the chance to look at varying our shot, like do we do 1 shot or 2 shots per location? Can we vary our system pressures to get those injectates distributed? Can we change our volume? And really by the time we finished our first transect, we kind of optimized for the lower half of each zone and the upper half of each zone within the transect, looking at, for the deep zones, 1 300-gallon shot, and then for the shallower zones, sequential shots of 200 and 100 gallons. And so in summary, again, load some questions up if you have them. This application could be utilized at other sites, right? The Ferro Black can be deployed for other metals as well, not just hexavalent chromium. GeoTAP has a lot of different applications, as you saw in some of those earlier slides. High energy DPT injection, applicable without GeoTAP even. Bedrock injection as well. So I'll end there and bring Ed back in to manage any questions that you have for us.
All right, thanks, Derek. It was excellent as always. We just have a few questions here, so feel free to send us more. We've got a few minutes. I think we can handle them all. We'll start with first, could a smaller pump have been used?
Sure, great question. So yeah, that's a fairly sizable pump, right? At this site, no. At the spacing we selected for the injection points, that triplex pump was absolutely necessary. Again, it was the distance between the GeoTAP points and the distribution we had to affect, right? Like as we move through each injection point, we are trying to interlock the adjacent injection point with each of those zones that we've injected in, right? So it's this interleaving, interlocking injectate that builds the transect. If the injection points had been closer together, like more of a typical overburden PRB setup, say 10 feet, 7.5 feet, 5 feet apart, we could have switched to one of our single or double pump setups. Those probably would have had the distribution we would have needed. Certainly at that depth, that 80, 90 feet, the double pump system does become more useful. But at this site here, that triplex pump was definitely necessary to create and build the transects we were looking for without having to install additional GeoTAP points.
Okay, very good. Were other reactants considered?
I believe so. We typically, though, see Ferro Black installed for hexavalent chromium applications like this. When the concentrations are this high, it does have significant reactivity. It also has persistence. There are other iron alternatives, some of them soluble, semi-soluble, others are solid. Cost comes into play. Longevity comes into play. Again, both the 30-year time frame and the concentrations we were dealing with at this site did dictate use of the Ferro Black So it was very applicable. But had this been a smaller site, had the concentrations been lower, had there been some other variables in the mix, there could have been. But we typically find that for hexavalent chromium, this is a very good injectate to deploy.
Okay. We have one here. When logging the sonic borings, were you collecting soil samples for hexavalent chromium analysis or just looking for preferential pathways like coarser zones to determine targeted injection intervals in the subsurface?
Great question. So when we were pulling the sonic cores for the GeoTAP, that was solely to identify the top and bottom of the transect in that GeoTAP point, right? Like we're kind of building a fence of GeoTAP points, but there was undulations in the top and bottom of the zone. So it did, thicken and thin in some areas. So we just wanted to make sure that every time we went into a GeoTAP point, we were installing the product within that zone. So there could have been, and there were instances where one GeoTAP point might have only had, 3 injection zones in it because it was very thin. Some were thicker. They might have had 8 or 9 injections in them. All the soil samples for design were taken well in advance of us heading out to the field. Those soil samples were also twinned with groundwater to allow us a synced evaluation of total mass that we were dealing with.
Okay, very good. Got another one here about Ferro Black. How permanent is the Ferro Black treatment? And does groundwater chemistry revert to pre-treatment conditions as upgrading groundwater flows into the treatment zone?
So the reduction of hexavalent chromium to trivalent chromium, in most cases, is a permanent conversion. There are some geochemical conditions that could change that over time, especially if there's also anthropogenic influences. I have seen it with re-injection wells or what we'll call groundwater cycling systems that are adding either oxygen or some other reactant to a groundwater unit that either overlies or is adjacent to where this is injected. And this would apply to a lot of different chemistries for metals, not just Ferro Black. But in our experience, the persistence of the product, and in most geochemistries, it is essentially a permanent conversion. And the regular criteria for trivalent chromium is so high that, even your native plus what you've converted, it'd be a very rare instance. And you can calculate it ahead of time because it is stoichiometric, but you can look at not running into that as an issue in the future.
Okay, good. You answered another follow-up question there at the same time, so I can move on past that. Let's see, can Ferro Black be used for other heavy metals?
Yep, that's a great follow-up to an earlier question. I've used it for hexavalent chromium, used it for aluminum, lead, and arsenic, but there are some other applications that we're looking at a site in the Northeast right now that has nickel. There's another site we're looking at, Pacific Northwest, with Ferro Black that has mercury concerns. So there are a large array of heavy metals that this is applicable to, but I would note that depending on the mixture of metals you're dealing with, there are 3 fairly standardized blends of Ferro Black that are sold, but they can also be slightly tweaked by the manufacturer if you have an odd geochemistry or an odd mix of metals.
Okay, see if I understand this question. After the injection, boring is backfilled with bentonite. The way this is worded, I think they're basically asking kind of about our pre-drill method. Going back down the same boring later for future injection to avoid doing the sonic drilling again. Maybe you can speak to that.
So reusing the point?
Yes, after it's been backfilled.
Okay, another good question. It can be, and as a matter of fact, some instances here in the Northeast, either AST or our client, depending on the intent of the installation, has completed the GeoTAP points with manways, well vaults, so they could be later probed through again. Specifically, we did that for a PRB in Massachusetts a couple years ago because the PRB setting, we were using an activated carbon called Boss 200 product, and because the amount of mass that was going to be coming out from a cavity that was inaccessible. It was filled with shot rock, and then there was some slab and some area we couldn't get to. The client just wanted to be in the future, if at some point they needed to augment the sulfate levels within that PRB, be able to go back through it. So there probably is a finite amount of time that point can be reused. We haven't run into it yet, but if you do a if you don't do a superficial completion on a GeoTAP point, the upper part of that column will start to desiccate, and at some point it will become too hard to probe back through. But right now, it looks like those points that we've installed at this other location, they still are probably probable at this point 4 or 5 years later because they've been sealed off.
Okay. All right, then I've got one more here.
Oh, Ed, if I might add.
Oh yeah, go ahead.
If you do, well, I'm just thinking if you do trip back in, you need to make sure that you previously, and you should have done this anyway, but absolutely have to repack a boring with hydrated bentonite. So you can have future reuse.
Yeah.
If you don't do that, you're going to leave void space or conduits that will be issues when you move back through it for injection.
Right, good point. Okay, one more quick one here. Would this same design apply to a shallower setting?
Again, it depends. We have done some very shallow GeoTAP installations here in the US. Generally though, if we can DPT it, and let's say the 7822 rig isn't big enough, you could move to something like a 3230. That's a fantastic rig. There's a couple AMS rigs that have a bit more power than the 7822. If those are getting refusal, even if you're really shallow, then yes, you're probably going to have to consider GeoTAP. But again, if you can probe it, we can skip the GeoTAP completely. And we have probed fairly deep. I think the deepest I've gone for high energy injection was a couple years ago in Alabama. We got down to 100, 125 feet was the deepest we injected. And that was a fairly tight formation down there. So that was a 3230. So if you select the right equipment, you can keep that flexibility.
Okay, well, I will go ahead and read another one here. It's kind of a little bit of a longer question for those who want to hang on just a bit longer past our 30 minutes here. Kurt says, clearly your procedures include monitoring injection pressures and piezometers for geochemical and indicator parameters to assess distribution of the inject date. Have you considered monitoring pore pressures, piezometric heads at offset adjacent and radially distant piezometer locations? And he follows on with, if so, have you seen a decay in pressures after injection as pore pressures begin to equilibrate?
That's another great question. And I am reminded that I did not mention it in my slide. We did install during injections in some piezometers and monitoring wells, we did put a pressure transducer to look for influence. That was very successful in assessing the distribution. And we had a fairly good monitoring well network adjacent to most of these transects. So we were able to see essentially in most areas, most injection events, we did see essentially immediate response in the formation hydraulically. We did not do what I'll say very precise evaluation of the hydraulic head and change. And by that, I mean, we were looking for a quantitative change further away from the injection because we knew based upon the pump pressure, flow rate, and runtime, essentially how far that inject date would distribute from that point in the subsurface. Again, based on experience, tables we've worked up here at AST, other sites where we've done confirmation borings. So the change in hydraulic head did again dictate the influence we were looking for, but we did not, so to speak, do precise calculations because we were looking for more quantitative peripheral influence than in the immediate area. In the immediate area, it was very easy to quantify on the transducers and piezometers.
Okay. Yeah, and I'd encourage really anybody who wants to get into more details about this to reach out to Derek directly. I see one more came in. suitable for vadose soil treatment?
It could be. That's a tough question to answer at this time without knowing more about the site. Some slurries and injectates can be deployed for vadose zone. Generally, though, you'd have to do a pretty good cost evaluation between that and say something with yellow iron. Now, if you have a very deep aquifer, maybe these injections make sense. Something like Ferro Black and some of the other injectates on that slide do not require groundwater, so to speak, right? Like something with activated carbon per se would require groundwater as a transport mechanism to bring the contaminant to the activated carbon, especially those flowing through that area. So in vadose zone, it's absolutely a contact sport, so to speak. So it could be deployed, but it may not be the most efficient or cost-effective method. But that's something that we could look at and could be considered.
Sure. Okay. Well, thanks again, Derek. You did a great job. Appreciate the audience. We appreciate that you all dialed in and had some great questions for us. Again, feel free to reach out to Derek, as you see his email on the screen there. Also, I'd encourage you to go to our website, astenv.com. If you're interested in seeing any recorded webinars, we've hosted a ton in this past few years, very educational about all the different technologies and RPI products. So when you're looking for a little learning over that first cup of coffee in the morning, jump onto our website, you'll find a lot. And also the RPI website, trapandtreat.com. A lot of really good information is available there. So thanks again, everybody, for being here today. We went a little long, and thanks to some good questions, it looked like we kept the interest of a lot of people staying dialed in past our 30 minutes. So hope you all have a great rest of your week, what's left of it. And feel free to reach out, and we'll talk to you sometime soon. Thank you.
Thank you, everyone.